Hello friends, today we are design and detailing of dog-legged staircase using IS code method. Okay, so first of all we put the length we put just a minute. Okay, we length of staircase we put the 4 meters. Width okay, floor to floor height I will take 3 meter. Then FCK 20, FY 500. Okay, you can take 415 also, but I will considering 500. I will consider riser 150, trade 250. It's okay. Landing width is 1.2. I will consider this also 1.2. Okay, support of width support we consider 230, and number of risers we calculate. We assume number of risers, let me 10. Okay, fine. Height of each flight 1.5 meter. Okay, you can see the plan also. This is the plan. Okay, this is the 4 meter length. This is the landing. Okay, and this is the section. Okay, now assume diameter of bar I will assume 10 mm. Just we see what will happen. Okay, modification factor is I will consider 1.3. You can assume in between 1 to 1.5. I will assume. Okay, I will calculate the trial depth, so using this formula, so I will get 180, and required depth is 212 mm. Okay, so we assume 220. Okay, so d provided is small d provided 195. So we calculate the load on steps. So first of all we calculate the dead load on west slab. Okay, so dead load on west slab, how I will calculate it? By using this formula we calculated this dead load on west slab. After that we calculated dead load on steps. So using this formula I calculated this dead load on steps. Okay, fine. Now after I calculated the floor finish, I assume it's 1.5. It's okay, I will assume 1.5 kilonewton. Okay, after live load I consider 3. Okay, total load is 12.79 by considering all this. Okay, all this dead load, live load, floor finish. Okay, factored load. After we apply the factored load by 1.5. Okay, so after we calculate the dead load on load calculation on landing. So how I calculate the self weight of slab? First of all I'll calculate it, this one, the self weight of slab. After that live load, floor finish load, and total load is 9.75. Okay, and factored load is 14.625. Okay, this is the loading diagram, how it will be the load apply. See how I load whatever the load I calculated, I applied for in this diagram. Okay, fine. So after that I calculated the reaction RA and RB. After calculation of reaction I calculate the bending moment and shear force. Okay, so I will check depth. Okay, depth is okay, the required depth is 141, and we provide the depth is 195. Okay, fine, its check is okay. After the main and distribution is still, I assume the AST requirement is 662. Okay, 688, sorry. So 8 bar I assumed according to 8 bar, and distribution is 264. So I assume 8 bar. So this is the spacing provided. Required spacing is like this, so I will change this spacing to 1110. Okay, so this one is also required spacing is 190, so I will increase this spacing. Okay, I will increase this spacing. I will go to data validation. Okay, I will write here list 100 110 120 130 140 150 160 170 180 190 200 210 220 230 240 250 260 270 280 290 300. Okay, fine. I will put these values. Okay, now I will take the values of 190 I will require, 200 I will provide. Okay, the requirement is, okay, I will reduce this, sorry. If 190 is required, we reduce the spacing to 180. This one also, this one is okay, it's no problem. 110 I will provide. Okay, so after that, this is the main style, this is the distribution style. Okay, it's failing in depth, so we need to increase the depth of provided depth. So we increase to 50. I will check what will happen. Now it's safe in deflection. Okay, now we calculate AST required, AST provided. After that, we check for deflection. Deflection check is okay. We calculated the shear force, check for shear. So after the shear, it's also okay. Now we calculate the development length. So like this, the development is this is the detailing of the staircase. Okay, fine. The final conclusion is 10 mm bar 110 mm center spacing main steel, and distribution is 8 mm bar 180 mm center to center. Okay, fine. Okay, I will show you, this is the all data, how we are consider all the things using IS code. Okay, fine, thank you.